Okay, so we're on lesson 1.4 on page 60, and you have a chart that you have to fill in. And so I'm going to walk you through the first one, and after I walk you through the second one, I don't think you'll have any problem doing the rest of them. So what you have to do is you have to go back and look at the scenarios that were in chapter 1.1. And the first scenario starts on page 5. So the first scenario is something's fishy, and that's been filled in for you already. Let's go through that scenario. So what happens is you've got a person who has to clean a 200-gallon aquarium. They pull the plug on that thing and it drains at a constant rate of 10 gallons per minute. Okay? So you've got some things to fill in. First off, function family. Well, let's think about this. The key to the function family is the constant rate. Okay? If something's moving constantly on a coordinate plane, it's going to be steady in a line. In other words, it's not like the tank drains a little bit, and then, oh my God, just it starts to gush out. It's a constant rate of 10 gallons per minute. So it's going to be steady downhill. And when you have that steady downhill, you're going to get a linear function. Okay. All right, our next spot we have to fill in the domain. And is it discrete, D for discrete, or continuous? Okay, so our domain is going to be our timeline from 0 minutes to, I don't know how many, let's say final minute. And if we actually did the math, we would be able to figure out how many minutes it takes for this tank to empty out. So actually we could do that real quick. It's a 200-gallon tank. It's draining out at 10 gallons per minute, 20 minutes. So our domain is 0 to 20 minutes. Now, is it continuous or is it discrete? Well, if it's discrete, it would look something like this. The chart would have the dots. But here's the deal. Remember that if you time it, if you're looking at how much water is in the tank every minute, 1 minute, 2 minutes, 3 minutes, there is water in the tank in between the minutes. So in other words, it's not like you just look at it after 1 minute and then there's no water. It's constantly going down, and there's always water in the tank until the very end. So that's a continuous situation. All right. Sketch. Well, let's talk about the sketch. The tank starts full. So it's going to start high, and it's going to go down at a steady rate until it hits 0, and then it's done. Remember, you're not going to get into negative numbers because you can't have less than no water in the tank. You can have no water in the tank. You can get to 0, but you can't get less than that. So there's our sketch. Next, does it have a minimum or maximum? In this case, hey, wait a minute, it's got both, right? Because at 0 minutes, it's got 200 gallons, and at 20 minutes, it has no gallons. So in this case, it has both. And last but not least, is this an increasing function, a decreasing function, or is it both? And I think you're looking at that going, oh, come on, Mr. Steinman, that's obvious. It's going down. And because it's going down, that's a decreasing function. Okay, so what you need to do is you need to look at the rest of the scenarios in 1.1 and then fill in the chart that's on page 60 and 61. So do that, and you're in good shape, and we can move on to the next assignment.